this is my mom. What I do? It's so weird. All right, Mom. So I've asked you here today to try to explain to you a concept in our class that we're learning about blockchain.
Okay.
And the goal here is just to explain it to you in terms that you will understand. And hopefully by the end of it, you can take something away. So you've been a teacher for what, 30 years?
33 years.
33 years, wow. And that's predominantly first grade?
First grade, except for 1 year in third grade. Yeah.
All right. So you're fairly familiar with the concept of an attendance sheet, correct?
Absolutely. Used it for many years. Even when we went to computers, I still had my handy dandy binder.
All
Yeah.
right. So what do you typically put in your attendance binders?
Well, I had, of course, the kids' names. I had the dates because I had to know what date everybody was there. I would put checks or X's if they were here or there. I'd put grades. I'd put if they paid lunch money, if there was any kind of attendance that they were half a day or left early or whatever.
Mm-hmm. So that's pretty similar to what would go in a blockchain in the individual blocks. And I'll first explain that to you. So a block in the blockchain can be thought of as just a sheet of paper in your attendance binder, right?
Okay. Mm-hmm.
It's going to have a title up front. It's going to have the actual data, which is going to be, who paid lunch money, who was in attendance that day, etc. And it's going to have the ender, kind of like a summary, the total of everybody who attended, maybe all the money that you've collected today.
Mm-hmm.
So you can think of a block as just that one sheet of paper. Now, when we talk about blockchain, we want it to be connected, right? Obviously, it's chain of blocks. That's why it's called blockchain.
Okay.
So the way that these blocks are connected is similar to if you were to take a picture of each sheet after the day is done and put it at the top of the next sheet, right?
Okay.
So now you have a compressed version of that first sheet and you put it in the new sheet, and now it becomes a part of every new sheet. And you do that over and over, and this makes sure that one part of the sheet cannot be changed. And that's a concept called immutability, right? These blocks cannot be changed once they're set in stone. Similar to if you laminated each page of your attendance book, right? You would notice if somebody went back and cut out the picture and changed it with a different one, right? You'd notice if somebody went back and said that Jimmy paid an extra $20 for his lunch. It wouldn't line up with that compressed version, what we call a hash in terms of blockchain, of the data that you had the day before.
Okay. So does each page in the chain, you said it would be like it was posted at the top. So as you're going through your chain, it's having more and more pieces at the top to show that you've had 5 pages or 5 pieces before, and then 10, and then 20.
Great
so
question.
It just keeps on.
Yeah, so I get your point. You would be worried about it getting longer and longer, but the way blockchain counteracts that is through a thing called hashing. So hashing, basically, it's like if you scanned your binder in and then came up with a number to uniquely represent the state of that binder, right? So if one person's attendance mark changed from a check to an X, that number would be wildly different, right? So we take that number, and similar to the picture of your whole attendance sheet from the day before, that number becomes the top, what we call a header of your next block. So that's the way that we keep the block from becoming too long, is by condensing everything that's come before it. So it basically creates a snowball effect to where if you go back 40 blocks and try to change one little transaction, then the entire block will be different. It'll be radically different.
Okay.
So do you understand the concept so far?
I do understand the concept, but my question is, I know as a teacher what I use the attendance book for, what it was used for, and how it was helpful throughout the year. But what would the average person use a blockchain for?
So think about something like money, right? That's currently one of the biggest uses for blockchain technology, is something like cryptocurrencies. If you've ever heard of them, you've got Bitcoin, Solana, Ethereum. All those cryptocurrencies are based on blockchain technology. So the way it works is when you record a transaction to the blockchain, it becomes a part of that data. So similar to you recording attendance or lunch money information, blockchain technologies can be used to record transactions. And through the recording of these transactions, you will always know exactly who has what money. So it can be used in banking as a faster and more efficient way to transparently record these transactions, as well as the immutability portion makes it much more secure in terms of people going back and undoing transactions. And you might ask, if you can't undo a transaction, how do you fix a mistake, right? Well, you can just add more to the blockchain. So it's continuously moving forward.
Okay. So it's more likely to be used in a business sense than an individual using a blockchain in their stuff at their house, keeping records of their bills or whatever.
Absolutely. Well, so that's an interesting point, is that it sounds like a technology that's only accessible to people with millions of dollars to invest into this new and innovative technology. But there's one concept that causes blockchain to be accessible to almost anyone, and it's called decentralization. Decentralization relies upon a bunch of connected nodes, which you can think of as computers, or in the attendance analogy, teachers, right?
Okay.
To all hold a copy of the blockchain. So imagine if all of the teachers in your hall came together and shared the same copy of that attendance binder. It then lets anyone check if something has been changed. Everybody can vote and come together at the end of the day and say, I have this total, does everybody agree with me, right? And that makes it accessible to almost anyone in the world. As long as you can connect to the internet, you can connect to a blockchain.
Okay, that does make sense. And we did similar things like collecting field trip money or something as a group.
Absolutely.
We had to do that on pencil and paper as a group.
Absolutely. And that's where something like blockchain technology could come in and completely replace the way you already do it.
So you just said that anybody can access the blockchain, but is it accessible to anybody? If you have a blockchain, can anybody get into it, see your information, or do you have to have a special passcode? Do you have to be invited to join that group, or how does that work?
So it's a lot, it depends on the blockchain, right? So different blockchains can be public or private. A private blockchain can be used for something like keeping your own tax records, right? Or your own money records, your own cash records. Any type of transaction or data that you want to upload to your own private blockchain. But when we talk about stuff like cryptocurrency, like Ethereum and Bitcoin, it's typically a public blockchain. So this public blockchain lets anyone connect and download that whole blockchain and upload transactions to it. And it relies on that decentralized technology architecture to host itself on each node, right? On each teacher, in each classroom, in each computer. So anybody can join.
Okay, so do you think there would ever be a need to go back and see which teachers inputted the information or changed the information in that blockchain? Would there ever be a need to do that, do you think?
Absolutely, and that's, because of the decentralized nature of blockchain technologies, especially when you're dealing with cryptocurrencies, right? Anybody can open a wallet. Anybody can create a wallet and use that wallet anonymously. The only thing that ties you to that wallet would be saying, hey, I own this wallet, right? So when we talk about going back and analyzing the blockchain for purposes of fraud or tracking down, illegal activities, that's absolutely something that can and has been done in the past. In fact, law enforcement can go back and track blockchain wallets to illegal activities. And if they catch one person who maybe put their wallet out there and said, hey, this is me, send me some money, they can then tie that wallet to that person. And similar in your analogy, you could ask all your teachers, hey, what's your number for your wallet, or what's your wallet address is the term used a lot. What's your wallet address? And then you could track on the blockchain who sent money where, which wallet address went to which, etc.
As a teacher, if I would have lost my black binder, I kept that very close to me. And if I would have lost it, it had lots of information that I didn't want to have to go back and redo.
Mm-hmm.
So it wasn't a problem with it getting hacked or it getting, computer-wise stolen, because it was in my hand. But is it safer to do, is blockchain able to be hacked? I guess is what I'm asking. Is it safe to have all that information in this blockchain, safer than any other way to do it?
Yeah, so when you talk about blockchain being hacked, like I said earlier, there's a snowball effect that occurs. So when you're taking that binder page and taking a picture of it and coming up with that number, what we call hashing, again, that hash is going to be the top of your next block. So if you were to go back and change even one little detail on that front picture, that hashing algorithm would completely spit out a different number, right? So that number would then snowball and change that block. So then when you hash a different page, that same page but with a different top number, it's going to then spit out another different number, right? And it snowballs to where you get completely unverifiable numbers. And that decentralized architecture, once again, every other teacher would come to you and say, hey, your binder is incorrect, right? Your binder is completely wrong. This is what I have. This is what everybody else has. We all agree. And it operates on that consensus model of the majority is correct, right? So theoretically, you could hack the blockchain if you got a majority share of nodes, in your case teachers, and told them something that wasn't true. But we like to call that statistically impossible, because the blockchain, in terms of things like cryptocurrencies, Bitcoin, they're so widespread and there's so many nodes that even to compromise half of the nodes would take immense corruption.
Okay, so question is blockchain something that's currently being, has been around a while, and I just haven't heard about it, or I just haven't understood it, or is it fairly new?
So dating back to the early 2000s, people that we like to call nerds, they were researching into this blockchain technology. There's a lot of significant figures like Adam Back, who researched technologies like blockchain 10, 20 years ago, and still continue that research and finding applications for blockchain technology. In terms of technologies overall, it is fairly new, but the reason it has been kind of hidden in the background is because it originally started with all of these cryptology nerds just experimenting on a better way to privatize their transactions and internet access. So given what we've talked about already, do you have a better idea of what blockchain is and how it can be applied into everyday life?
Sure. I mean, it does make more sense when you break it down to the parts, and when you related it to something I could understand, which was the attendance book or my black book, and using the teachers as the nodes. And so using all that, I can see where it is applicable in the real world, and get pretty much the same information as we did pen and paper wise. So it does make more sense.
All right, sounds good. Well, thank you for joining me. I look forward to dinner.
Okay, great job explaining. Thanks, Adam.
Thank you.